Limits never really leave us in calculus. Sequences are also something we need to take the limits of. The good news with sequences is that we will always be doing the limit as n approaches infinity. We don't do any other type of limit because it really doesn't make sense, because our domain is just the natural numbers. So since we can only be at the whole numbers or the natural numbers, it's not like we can see what it's approaching at 1.1 or 1.01 or anything like that, because it doesn't even exist there. It only exists at 1 and at 2 and at 3. So it pretty much has a value or it doesn't, is pretty much what it boils down to. So the only thing we will ever do the limit of is the limit as n approaches infinity. So if they just ask, find the limit of this sequence, you know automatically they mean the limit as n approaches infinity. Okay, and there's two words you need to know when it comes to sequences and their limits, and that's converge and diverge. If you get a finite answer, in other words, when you take the limit, if you get an actual number, that number can be 1/2, 75, 3, -2, whatever. If you get a number, then that sequence converges. Converge just means you get a number. Now, if you get infinity, positive or negative infinity, doesn't matter which one, or you get does not exist, that means diverges. You probably won't get does not exist real often, but you will sometimes. You will sometimes. So anyway, if you get infinity or does not exist, then the sequence diverges. Finite answer converges, infinite or does not exist diverges. Okay, so let's start with an example. The limit as n goes to infinity of 1/2 to the n. And I'm just going to pull this one up in the calculator. Same way we've done infinite limits before, we can plug in the equation into y equals, and we can go to our table and just plug in 10, 100, 1,000, and you can tell that it's clearly going towards 0. Clearly going towards 0. So next example, we have the limit as n approaches infinity of 1 over 1 plus n raised to the n. So here y equals, we do parentheses 1 plus 1 over n raised to the n, and we're going to infinity. I don't know if you recognize that number, but it's a very common number, believe it or not, and it's actually e. So we are approaching e. Now this isn't something you have to know, but if that structure over here looks familiar, it's because it's the interest equation. If you remember, the interest equation looks something like this. So hopefully you can at least see how they're related to each other. I know it's not perfectly the same, but that's how the interest equation turns into PE to the RT, is they take the limit as n goes to infinity, and you end up with that. So that's actually where e comes from. This is the definition of e. E originated when they took the interest formula and wanted to know what it was to be continuously compounding, and took the limit as n goes to infinity. So, just some free information there for you. Let's do the limit as n approaches infinity of 3 plus -1 to the n. So we do 3 plus -1 to the n. And clearly the limit's 4, right? Actually, it's wrong. This is a tricky one, and this is one reason I brought this one up. It's important that you pay attention whenever you have a -1 raised to the n or a negative anything raised to the n. If that happens, you need to not only check even numbers, 10, 100, 1,000, and so on, but also check odd numbers. So I'm also going to plug in 9, 99, 999, and so on. Because you can see that gives us two different results. So if you remember back to a previous video when we looked at the first 5 terms of this sequence, it just alternates between 2, 4, 2, 4, 2, 4, 2, 4. So the limit as this goes to infinity just doesn't exist, because we're not going toward any one number, we're just bouncing back and forth between 2 and 4. So since this does not exist, another thing we could say about it is that it diverges. So our first two answers converged. 1/2 to the n converged to 0. 1 plus 1 over n to the n converged to e. But 3 plus -1 to the n diverged because the limit did not exist. Last example, the limit as n approaches infinity of n over 1 minus 2n. You can still plug this in the calculator, but I also wanted to remind you the old rules still apply. We've talked about powers being bigger on the top or the bottom and what that means. Well, here the powers are clearly the same. We have an n on top and a negative 2n on the bottom. Those powers are the same, so you just go with the coefficients, which would be 1 over negative 2, so it's negative 1/2.